we're going to talk about the fundamental theorem of calculus today. So we've kind of talked about antiderivatives and integrals. We're going to actually take it and kind of combine those to the definite integral. So the mean value theorem for definite integrals, we kind of looked at this. F of c equals 1 over b minus a. The integral of a to b of f of x d of x. So we know we have this function. We know this is the case. C is somewhere between a and b. We can find that when we take the antiderivative. So the first part of the fundamental theorem of calculus says that if I have a function, if I have the derivative of the function, that gives me the f of x. So if I have the integral of f of x between a and b, and then I take that derivative, that also gets me to f of x. So it's saying, hey, we have this function. If we take the derivative, we get to our original function, so to speak. This is where we're going to spend most of our time, is in part 2. So if I have this definite integral of a to b of f of x d of x, so I know I'm taking the antiderivative of f of x with regards to d of x, what I'm going to do is that's going to be f of b minus f of a. So I'm going to take the antiderivative, I'm going to plug in b, I'm going to plug in a, and I'm going to find the difference there. Okay? So we're going to use this fundamental theorem of calculus here to find these definite integrals. So what happens is I need to find the antiderivative of cosine. So the antiderivative of cosine is sine of x. And now I'm going to evaluate that at pi and 0. So if you remember back, the antiderivative would be sine of x plus a constant, right? And it's still that, okay? So it really is plus ac here, and I'll write it here, and then we'll kind of look at this. So what I'm going to do is I'm going to go sine of pi plus c minus sine of 0 plus c. Well, what happens is I have c minus c, so it gets rid of that constant. So a lot of times we won't write it. We'll just write from 0 to pi. Sine of pi is 0 minus 0 equals 0. I have no area between of cosine between 0 and pi. It works out to be 0. So I have a part above, part below, works out to be 0. So now we're going to do this next one. And when we take the antiderivative, a lot of times if we're taking the power rules, what we're going to do is we're going to add 1 to the power and divide by that new power. So this becomes, I'm going to add 1 to the x squared, I get x cubed. So this becomes 1/3 x cubed minus 2x squared over 2 plus 3x. And I'm going to evaluate that at -1 and 1. Well, I'm going to kind of adjust this a little bit. Okay, so now I'm going to have 1/3 1 cubed minus 1 squared plus 3 times 1 minus, and now I'm going to plug in -1. 1/3 times -1 cubed minus -1 squared plus 3 times -1. Okay, so this gives me 1/3 minus 1 plus 3. So now I'm going to kind of incorporate this. So minus, and then I have minus 1/3 minus 1 minus 3. Okay, so now I'm going to add all these up. So here I have minus 1 plus 3 is 2. So here I have -4, but that becomes a positive 4. So I end up with 6. 1/3 plus 1/3 is 2/3. So 6 2/3. I probably wouldn't write this like that. I'd probably say 20/3, and there's my answer. Okay. So my next one, I have the product of 2 items here. Well, when I'm doing this, I want to actually physically multiply this out first. So I'm going to go the integral from 1 to 2. I'm going to go t cubed plus t squared plus 4t plus 4 dt. And now I'm going to take the antiderivative. So I'm going to add 1 to my power. So this becomes t to the 4th over 4 plus t cubed over 3 plus 4t squared over 2 plus 4t. And I'm going to evaluate that at 1 and 2. So 1, 2. Okay? So now when I plug in 2 here, I get 2 squared, so 2 to the 4th power over 4, plus 2 cubed over 3, plus 2 times 2 squared, plus 4 times 2, minus, and now I plug in 1. So I end up with 1/4 plus 1/3 plus 2 plus 4. Okay? So I'm going to have a little bit of work here to do. I have some fourths and I have some thirds. So I'm going to go ahead and simplify this a little bit. Okay? So 2 to the 4th is 16. 16 over 4 is 4 plus 8/3 plus 8 plus 8 minus 1/4 minus 1/3 minus 6. Okay, so I'm just going to kind of simplify these a little bit more. So here I have 16 minus 6 is 10 plus 4 is 14 plus 7/3 minus 1/4. Now I got to get these all in 12ths. All right, so let's see. Well, 14 times 12. 3, 38, 28. Okay, so 168 over 12 plus 28 over 3 minus 3 over 12. So that should be 12. And let's see, so that's 20. 25. So 193 over 12. Right. So 96, 193 over 12. Okay, so a lot of times you're going to have to do that with those fractions. You're going to have to simplify it. We typically don't want to put this in like a decimal form. We want to leave it as a fraction. Now the last one we're going to talk about is, notice we've done a lot of simplifying before we take the antiderivative. Well, we're going to do that again. Okay, so I'm going to simplify this. This becomes y to the second minus 2y to the negative second dy. Now I'm going to take the antiderivative of that. So I'm going to add 1. So this becomes y cubed over 3 minus 2y to the negative first over negative 1. All right, and I'm going to evaluate that at negative 3 and negative 1. So I'm just going to do a little bit of simplifying. Y cubed over 3 plus 2y to the minus first, negative 3, negative 1. Now I'm going to plug in those values. So I'm going to plug in negative 1. So I have negative 1 cubed over 3 plus 2 over negative 1 minus, I'm going to plug in negative 3. Negative 3 cubed over 3 plus 2 over negative 3. Okay, so now I'm going to just keep on simplifying here step by step. So this gives me negative 1/3 minus 2 minus, so this becomes negative 27 over 3, so negative 9, so minus negative 9 minus 2/3. Okay, so this is going to give me positive 9, so that's 7. So that's going to give me 7. This becomes a positive 2/3 minus 1/3 is 1/3, or 22 thirds. So when we're doing this fundamental theorem of calculus is how we find the area. Last week when we first started talking about area underneath a curve, we were talking about adding rectangles and getting estimates. This is actually exact area under a curve, is we're using the antiderivative between those 2 points. Okay.